So, in this lecture, we start looking at pottery, a very important type of stuff that is probably more important to archaeologists than it actually would have been to most of the people that made and used it in the past, because of its very specific nature, which I shall be telling you about in this lecture. So, pottery, unlike metals and glass, pottery cannot be melted down and reused. Once it is broken, it is thrown away. Unlike metals, it cannot corrode. Remember all those oxides of iron and copper and sulfides of this and that. Pottery doesn't do that. Unlike wood and other materials, textiles and things like that, pottery doesn't rot. Hence, it is generally the most common find on a particular archaeological site, and in some cases it may be the only artifact found at a site. All of this is important, even if it doesn't have a green arrow. Just basically green arrow everything. For example, this is a site on the coast of Yemen. Here's Yemen, here's the Red Sea, called Galaifica, where I did some work in the 80s. This is Galaifica, and this is what's left of the archaeology. It's a deflated site, so most of the site's been blown away by the winds of the desert and the sea, and all that is left is the pottery. So the only thing we know about the people that lived on this site and material that will inform us of their lifeways and their behavior is the pottery. That's all there is. So, pottery is easy to shape and to decorate. Hence, pottery always reflects its contemporary tastes and cultural ideals. So, whatever you want to form, you can make it out of pottery. It's, well, within reason. But there's a lot of imaginative things you can do with pottery, and a lot of distinctive things you can do. For instance, these well-known terracotta warriors, every one was a unique face. And so pottery is very useful for doing unique things. So pottery is primarily made of clay. Clay, of course, is a naturally occurring fine-grained sediment. This is clay. This is from the Upper Paleolithic of France, and they've modelled these bison out of clay. Clay tablets are made of clay. They've just been modelled like a lump of clay and had signs pressed into it with a wedge-shaped thing. So to be used in pottery, this deposit must comprise, or certainly include to a significant degree, clay minerals. So not all clays are filled with clay minerals. They're just clay-sized particles. So clays, of course, bring back the old silicon tetrahedron and aluminium octahedron that we talked about in earlier lectures. And together, these make the building blocks of the phyllosilicates. Remember the phyllosilicates? And phyllosilicates will include the clay kaolin. So here's the aluminium oxide and the silicon oxide together with water. Although this is actually hydroxyl, you can just think it's called water. And this is in between these sheets of silica and aluminium and oxygen together. And so a lot of other phyllosilicates, like the micas, can make very large crystals, as big as a car. But the clay minerals, by their nature, can only make small crystals. It's impossible for a clay to be larger than, 0.2 millimeters or so. So there are a number of minerals. I've been asked if students should remember the formulas. That's like improbable, don't you think? So no, and just remember there are a lot of clays. You might want to remember kaolin, because it's such a nice clay. So, back to what is pottery. So clay can be made very soft and plastic when it is wet, and may be formed into any shape. Clay minerals include water in their atomic structure. Yes, I'm going over the same points, don't worry. To turn clay into pottery, it must be fired by being made very hot in a fire or a kiln. When clay is fired, the structure of the minerals is destroyed forever, and they become a glassy mass. So that water within the very structure of the clay is driven off by the firing, and so that crystalline structure is destroyed and can't be rebuilt. That's why you can't recycle pottery. So this fixes the pottery into its shape forever. So people have been making their pottery hot for some time, just taking a clay thing and firing it. Chinese archaeologists claim to have found the earliest vessels made of fired clay. Then there is, of course, the well-known Jomon culture of Japan that made possibly the most interesting pottery ever made. And there's also recent finds from Mali of what appears to be very early pottery. So pottery in the Middle East is not quite as exciting as it used to be. Maybe if we looked for it, we might find it. But typically, 7th millennium BC or so, we get pottery. And it's very nice pottery. You can see it's quite well made. This is probably what we call a pinch pot, where you just like pinch it together with your thumb and your fingers to draw out the clay. And we'll be talking more about forming techniques in a later lecture. So along with the clay, you may need temper. Now, temper are also called at times aplastic inclusions, distinguished from the plastic inclusions, which is the clay, which collectively makes clay a plastic medium. But these inclusions are not plastic. They're just like they're being aplastic. So these can aid workability during the working. So when you're making pottery, sometimes a clay that is rich in clay minerals is very sticky. And so if you add aplastics to it, it makes it easy to work. It reduces shrinkage during firing, which is actually what this image is about. You can see the little white bits in here. That's the temper. This is probably the mineral calcite, or another mineral which is also white, but it's probably calcite. In fact, this looks like shell. So you can see this is being stuck on this piece, and you can see that this is the boundary. This is a handle attached to a vessel, and you can see the handle has a lot more aplastics in it than the actual wall of the ceramic vessel. And this is because they allowed the ceramic vessel to dry. So basically, when you make a clay vessel, you first allow it to dry, and then you may want to make it quite warm to drive off as much water as possible, and then you will fire it to destroy any water left in the atomic structure. So this one's been allowed to dry and then had the handle attached to it. Because the clay shrinks, if this had been added and had the same amount of clay, it would probably shrink so much it would fall off. Of course, another alternative would be to attach the handle to the vessel while they're both at the same degree of dryness. But this is probably some sort of mass production at the time, adding the handles after making a lot of vessels. So aplastics also provide desirable properties during firing. So in the firing of the vessel, it may enable outgassing, for instance. There's a lot of gases in the firing process, water coming out of the clays and this sort of thing. And so it may create the necessary porosity or create the conditions that make firing more possible. And it will provide desirable properties to the finished vessel. So you fired the vessel, you have this pot in your hand, and the temper makes it work better for you. An example would be cooking pots. Cooking pots often have temper in them that is of a particular type. For instance, calcite. Remember the mineral calcite? Calcite expands and contracts in heat at about the same amount as pottery does. So it works very well for a cooking pot. But the mineral quartz expands and contracts at very different rates. So if you have too much quartz as an aplastic in a cooking pot, it will blow up your cooking pot while you're trying to use it, whereas calcite will not. So the temper has provided desirable properties to the finished vessel. So there are a number of types of fireclay ceramics, 3 main types really, based on the temperature of the firing. Earthenware is a relatively low fired clay ceramic, about 700-1200 degrees centigrade, which is what most of the pottery we find in the Middle East, that is made in the Middle East, is fired to. So from the Neolithic up until the Islamic period into the 17th century, most of the pottery is fired to earthenware temperatures. Very rarely you might get stoneware fired to a higher temperature, about 1200 degrees to 1300 degrees centigrade for stoneware, and you will find stoneware on archaeological sites in the Middle East, but it tends to be imported from East Asia, like China, like this piece. And then you have porcelain, which was never made in the Middle East up until the 19th century, and in this case it is definitely entirely imported from China. So these are the main types as dictated by the firing temperature, and you may have also different types based on the type of clay or what has been modified from the clay, and some ceramics are actually mostly made of quartz, not made of clay, but we'll be getting onto that in a future lecture. Another important aspect of firing the pottery is the fugacity. And this is related to how much oxygen there is. And you'll have reducing atmosphere where there is no oxygen, and oxidizing atmosphere where obviously there is oxygen getting into the kiln. This is an interesting pot which seems being fired under both conditions. And apparently it's thought that the way this was done was this was fired upside down, sitting in a pile of ashes. So the kiln was fired under reducing conditions at first, and the pot was fired black, and then the kiln was open. This actually happens quite often, and the kiln became oxidizing and the pottery turned red as if it was buried in ash. You'll often get cores of the pottery will be a different color to the exterior, and this will be due to the same reasons. So let's go through the production of some pottery. This is a clay pit. This is a medieval clay pit for quite a decent sized production center in the Yemen at a town called Haiz. And pottery made here went all over the Yemen, all over Saudi Arabia and Arabia, and was traded into the Red Sea and down to East Africa. So it was quite a big hole in the ground. So you can see they've dug into the alluvium to get clays, which were then used in making pottery. So once you get your clay out of the ground, you will want to process it, and there's all sorts of strange voodoo potters do to their pottery raw materials in order to make it workable. If you ever go and talk to a potter, they quite often go to something that doesn't actually look like a clay deposit to you, and if they then process it, and it could be like what looks like a bed of shale, they can break it down, hammer it, leave it in a bag, a plastic bag filled with camel urine for 6 months or something like that to break it down. All sorts of strange things like this to end up with something which is actually a workable clay. But here you can see crushing of the clay. This is from a series of photographs published by a man called Owen Rye in his book Pottery Technology, which I would highly recommend. And I think you can easily get it at the library, but I think we may even have a PDF you can have if you ask someone nicely. This is actually one of my photographs taken in Zabid in the Yemen in 1989, where they were making pottery. And so these are the raw materials put together to make pottery. And it comprises a fat clay. A fat clay is a clay with a lot of clay minerals in it. So it's called fat because it's, I don't know, sticky. And it doesn't work very well to make pottery out of, because if it has too much clay, then it'll shrink too much, it'll be too sticky, it'll be unworkable. And so you'll want to add temper. But in this case, the temper, in quotation marks, is actually just another clay which seems to have more aplastics in it. And also being added is camel droppings. And so this is the material they add together to make the clay paste. So it is important to realize that when you think of temper, you may not be thinking necessarily of a clay to which you're adding a silty sandy material which then tempers the clay. You could be having two types of clay being mixed together, and there's lots of evidence for clay mixing two different sorts of clay to make material which is better than one or the other. The use of poo is due to it's very, very good. It's very fine fiber, and so adding fiber as a temper to pottery makes it very easily worked, and in the firing it'll just go away again. So that actually works really well. And it makes it, if the pottery is at all stiff, it'll make it more workable. So here we have a photograph from Hans Wolf's book, and you can see this chap is using this quern to process the materials to a very fine degree. This chap is now kneading the clay in preparation for making pottery, and this chap is making pottery. He's using a slow wheel. You've probably heard of throwing pottery on a wheel. This is a wheel, but that's not wheel thrown, it's just made on a turntable. And so it helps make it more concentric just by moving around as he's shaping it. Here we have a whole bunch more on this tomb. And so you can see here's another slow wheel. Here's a bit closer. And this is a whole series of potters with slow wheels, and they're making pottery. And here is presumably the clay being processed, and here is a kiln being loaded up here for the firing. So here we have another image from Owen Rye of pottery being made, and he's using a turntable as well, and he's put a lump of clay onto it. So then he's using coils. This is coil construction. And so he's adding a coil to that flat slab he put here and building up the rims of this vessel with that. So now he's using a tool. So this has been built up with coils which have all been smoothed together, and he's using this tool to create the rim and turning the turntable as he does so to make it nice and even and round. So now he's decorating it. So he's probably rouletting this as he's turning it on the wheel. Here now he's happy with that end. He's shaping the other end with yet another technique, the paddle and anvil technique. So in this he's probably got like a rounded rock or something in one hand, this hand going into the pot. And at this end he has a paddle. And so he's pounding away at the outside to make it a nice rounded bottom, like this. So now he's smoothing the bottom with this paddle. So then we come to the fast wheel. So this is what we use to throw pottery. And here you can see I haven't actually ever seen this in real life. This is a kick wheel, which I have seen, but it's at an angle. And so I assume that what this means is as he's kicking down, it's creating more of an impetus. And so the wheel is usually heavy. It might be a solid stone or metal. And once you get it going, it really wants to go round very, very fast. And so he's kicking away at it with his bare feet. And it goes round. And there's a shaft that goes up to the pot where he's throwing it. Here's another one. This is a photograph I did take in 1996 in Iran. And you can see he's sitting at the wheel here, and here is the kick wheel, and one leg is up here out of there, and the other one is like kicking this as he goes along. And here he's at the business end, and he is doing what we call throwing from the hump. So what he's done, and one of the time-consuming parts of throwing pottery, is putting the clay on the wheel and centering it. If you ever have a chance to throw pottery, you will find this is what will cause the biggest disaster when you don't center it and place it properly when you start the wheel and it throws clay all over the room, which is a lot of fun, but not when you're cleaning it up afterwards. So centering the clay is a bit of a pain, so he's done this once, and from that he is throwing this bowl. Here he is, he's measuring it, and then he will cut it off with a string. This is another potter, so he's made these coil-made vessels, and he's now going around to finish it. In fact, he goes around so fast you think it was actually a wheel-thrown vessel, but it's not. So here is this chap back in Isfahan, and so here you can see they're making different parts of these vessels. So little dishes here, and there are these little bits, and they're sticking them together. So sometimes you need to build different components of the pottery together. Now this chap is painting them before the firing. So then we fire the pottery. This is an open firing, the simplest of all. We just put the pottery in the fire and it fires. And you'll get black marks on it, and it won't get to a very high temperature, but that's how you make pottery to start with. Then a pit firing is a bit better. It's basically a bit more controlled. And then you get kilns like this one, which is in Egypt. So he's taking his pottery and he's putting it into the kiln. This is an updraft kiln, in which the source of heat is actually over this way somewhere, or down here, and the heat is then blown into the kiln. So the fire isn't actually touching the pottery at all, just the heat goes in and comes out the top. So this is the sort of kiln they use to this day. Here, in fact, is a kiln being used, although this is not this day, it's 1996. And you can see it's being prepared to take pottery. These things sticking from the side are called kiln furniture. Kiln furniture is very useful because it's typically made of the same material as the pottery is made, but you don't trade it over a long distance. So if you find fragments of kiln furniture, you have found evidence of production. And this is very important for glazed pottery in particular, which is what this is. And so you can see on top of all this kiln furniture, they've mounted up all of this pottery, which has been painted and it's been glazed. So the glaze is a glass crushed to a fine suspendable material, which has then been painted or washed over the outside. And we'll be talking more about glazes in a later lecture. So now this chap is firing the pottery. So this is above the firing chamber. You can see it was also built over, because this is a good place to really dry out your pottery, because you don't want any water left in it at all, apart from the water in the atomic structure. So here they've piled up all their pottery waiting to be fired up in this very warm atmosphere. And he is looking down this hole because he's determining how high the temperature is. He's making sure it's hot enough, and it will be hot enough for long enough. And all he needs to do is look at it. And you can see this color is about here somewhere. It's a bit oranger than the yellow. So that's quite high. And we'll fire that pottery quite nicely. So after the firing, here you can see this glazed pottery. Now the glassy covering now covers all the vessel and has turned glassy as a glaze. So this is a video I made in Syria, and these are clay settling pans, and this enables the raw material to be turned into a better raw material, because if you sloosh all the clay in it, it settles out, and so coarse particles will settle first, and the clay, being not only very light but also flat, will settle last, and so that top material will be very rich in clay. Then you might want to sieve it like this one, crush it up again, and so then you will have, after mixing it with other materials possibly, your clay material. So these very nice gentlemen who I visited on a Friday, which is their day off, you can see that they're dressed in not their normal work clothes, but they're going to make some pottery just to be nice to the annoying foreigners who came. But they're very nice, being Syrian, and they're making pottery. So they're kneading the pottery. They're getting it nice and soft in order to work it. And now he's bringing it over to the wheel. So if you look at his legs, you can see this is a kick wheel. You can see they're moving. Every so often he kicks forward. And so this is a perfectly fine technique to use up until this day. It's good exercise, and you don't need power to do it, and it works perfectly well. And so here you can see the energy of the pottery being thrown out through centrifugal force from its core provides the energy which enables him to throw the pottery, to shape the pottery to whatever he wants. It really looks quite easy, doesn't it? I can assure you it isn't. It's one of those things that looks a lot easier than it really is. Like much technology in traditional technology in the world and ancient technology, it's actually much harder than you think it is. So the reason these chaps can take a day off, which isn't true for a lot of crafts people that I looked at in Syria, because as you can imagine, as an archaeologist, I'm mostly doing archaeology, so I get a day off. The Friday is the day off in Syria, and so I would often go and look at things and look at crafts people, and these guys could take the day off, unlike every other crafts people I went to study, because they're making this nice pottery, and then they were cutting open one side and making little scenes inside with clay, and then selling it to Germany. And Germany was importing vast numbers of these pots with these little ceramic scenes inside. And so they were quite well off and could afford to take the day off to go and pray and do that sort of thing. Okay, now he's going to make another one. So you can see the speed. He's centering it because you don't want to mess with this stuff. And then his thumbs go in and pull it up. So most of the energy from this is coming from the wheel. He's just guiding the clay to where he wants it to be. This is probably where you're wondering, what is he going to make with this one? Looks like he's making another vase, doesn't it? So now he's making the rim pretty. So you can see how easy it is to shape clay. It's very soft and very malleable. All it really needs is a lot of skill to make something worthwhile. See in there he's using a string to cut the pot off of the wheel, which is quite important because we see evidence of that in the archaeological record, which I will show you in a later lecture. And there's the finished pots, drying. You can see some of the more decorative ones. And outside they have a lot of pottery. This is the fuel and this is the kiln. So you can see it's an updraft kiln. It's empty. Otherwise we wouldn't better see inside it, of course. And here's where the fuel goes. And this big metal lid goes on top of the kiln when it's firing. And the fuel is all sorts of stuff that just seems to be floating around, including nutshells and, see, cashew nuts. So whatever works is fine. And so here's some of the pottery they make. So that is our introduction to pottery. In the next lecture we will continue talking about pottery.